picking up good vibrations.
In this video, we'll talk about systems, which are intimately related to signals. Since our focus is on signals, we'll talk about systems insofar as they tell us something useful for us in terms of signals. We'll start with the definition of a system, then a few examples and a few properties of systems. A system is any process that results in the transformations of signals. So there is an input signal that is transformed and results in an output signal. For discrete time systems, the input and output are discrete time signals, and for continuous time systems, the output and output are continuous time signals. Let's look at a few examples. For instance, multiplication by a scalar. You have an input in continuous time x of t, and you multiply that by alpha, you get y of t equals alpha times x of t. It's a very simple transformation and can model, for instance, an amplifier that we can use, for instance, to amplify our voice or make it lower. If alpha is larger than 1, we amplify. If alpha is less than 1, we make it lower. The power. It's a more mathematical system. It's a mathematical operation, which is the power. So if you have an input signal x of t, we can make the output x squared of t, and we call the output y. Delay. If you have an input signal x of t, we can shift it to the right and we obtain a delayed signal. Delay can model several things, for instance, a communication delay. First difference. If I have a signal x of n in discrete time, I can take the first difference, which is x of n minus x of n minus 1. The first difference is often used to detect sharp transitions of the input signal. If you have a signal that has a sharp transition, the first difference will be a spike at the output, which you can use for several purposes and to understand when the input signal changes rapidly. The analogous operation in continuous time is the derivative. So the output y is nothing more than x dot. We also have the cumulative sum in discrete time, which is the summation from L equals 0 until n of the input signal. That gives us the output y of n. The analogous operation in continuous time is the integral from 0 to capital T of x of s ds, and this gives us y of t. Finally, we have the moving average, which is useful in several contexts, which is nothing more than the average of the signal over a given window with r plus 1 values. And then we take the average over time. So the output, y of n, is the average of the previous r plus 1 value.